Hi, today we're going to talk about sinusoids. So, the sinusoid is the different equations that you get from the sine graph, and they're waves. And if you look at this first equation here, it's very complicated. We're not going to get quite that complicated. We're really going to deal more with this second equation. The A is the amplitude, and the D is the vertical shift. And so you've seen all these waves before in science where you can talk about wavelength and the period and the amplitude, and really we're going to talk about specifically the graphs of sine. And so you should notice a lot of things about sine. First, we're going to talk about how the sine graph goes through the origin right there. And remember, these things are what we call periodic functions, so they do the same thing over and over. Now, they are called crests and troughs. We do refer to them as hills and valleys, to be in layman's terms. So if you look at that, it's right between the hill and the valley that you're going to have the origin going through it. So sine, as you go left to right, goes up, and you get a maximum, and then it goes back down through the center line, and then you go down to get your minimum. That's the hill. The amplitude of this one is 1, and the vertical shift is 0 because it goes right through there at the origin. For these first few examples, I didn't change the vertical shift at all. I just changed the amplitude each time. So we start off with equals 1, and then this one, A equals 2. So your amplitude is 2, which means the distance from the center line to the crest is 2 units long. On this next one, A is going to equal 3, and then I just get a few other examples in there so you can kind of compare what they look like. And then here are several of them together so you can see them at the same time. Then I make the amplitude 2 for the next several of these, and the only thing I changed is the vertical shift. So you'll notice the entire thing is moved up. So it's just like a y-intercept on a linear function or any polynomial function. It's just going to be moved up or down, whatever that is. And so what you should notice here is that it does not go through the origin each time, but as it goes through the y-axis, you have to the left the valley, and to the right you have the hill. And right there where it changes is where the y-axis is always going to be. Remember what sine looks like, and so we're going to reflect it across the x-axis, and you're going to put the negative in front of it. And so this time when it goes through the origin, it's going to go down through the origin. And here I put a couple where you change both the amplitude and the vertical shift together so you can kind of compare them. And very briefly, I want to discuss cosine. The graphs of sine and cosine are a lot the same. So again, we're going to ignore the really complicated version of the equation and just use a simpler one. But look at this graph of cosine and see how it's a lot like sine. There's almost no difference. If you go back and look at the y-axis, that's where the difference is. So cosine actually goes right through the top of the crest, right through the middle, and that's how you distinguish between sine and cosine. But pretty much everything else is going to be the same.